Hello students. So we were doing exercise 1.3 question 9. Okay. So consider R plus F from R plus. I'll write here. Function is defined as f of x equal to 9x square plus 6x minus 5. Okay. Show that f is invertible with f inverse is defined. Now f invertible, you have to first find out your g of y. Okay, that is from minus 5 infinity to r plus, and then you have to compute both g composite f and f composite g. Okay, if they are equal, means if they are identity, then we can go forward, that is f is invertible. Okay, so let's say some y belongs to minus 5 to infinity such that f of x is equal to y, and this is equal to 9x square plus 6x minus 5. We have done one problem of this kind. Okay, that was in the examples. So you have to use here this, you have to convert into a plus b the whole square. So here we have, this is your a square. Okay, a square is 9x square, so your a is 3x. Okay, and this is 6x is your 2ab. So 2ab is your 6x. Okay, a is 3x into b. B we have to find. So x you can cut. You get 6 upon 2 into 3. So b is 1. Okay, so b square you have to take here 1. So I'll write, this is your 3x the whole square plus 6x plus 1 square. Okay, so minus 5 you have to split in such a way that this 1 remains. Okay, so you can write here plus 7 minus 6. Okay, so minus 6 plus 1 is minus 5, right? So you can write this as 3x plus 1 the whole square minus 6. Okay, so this is your y. We need x. That's why we are doing these things. Okay, so 6 you can take this side. So this will be y plus 6. And this will come here root. And this is 3x plus 1. So 1 you can take this side. I'll write here minus 1 upon 3. This is your x. Okay, and this function is your g of y. Okay, so I'll write it here. G is from minus 5 to infinity till r plus. Okay, and g of y is defined as root of y plus 6 minus 1 upon 3. Okay, now we have to compute f composite g and g composite f. So f composite g of y is f of g of y. So put here in place of x, you have to put this. Okay, so 9 whole square plus 6 into root of y plus 6 minus 1 upon 3 minus 5. Or you can take this, we had reduced, right? That will be easy. So this was reduced to 3x plus 1 the whole square minus 6. So now I'll put it here. plus 1 the whole square minus 6. So you can cut this 3, minus 1 1 goes, this root and this square cancels, and you will get y plus 6 minus 6, which is y. So f composite g of y, you are getting y. So this becomes identity. Okay. Next we have to compute g composite f of x. So g of f of x is this. Again you can make use of this. Okay. Put this in this. So this is root of 3x plus 1 the whole square minus 6 plus 6 upon 3. So square and root cancels. X. Okay. Again we are getting identity. So both we have got. So this is f is invertible. And inverse of f is f inverse y is g of y, which is root of y plus 6 minus 1 upon 3. Okay. So this kind of problems are very easy. First you have to write this, that is you have to write it in terms of y, that is you have to first find the another function that is defined from this set to this set, okay, that is g of y, and then you have to compute both f composite g and g composite y, and you have to show that both are equal, means both are identity, and then it is invertible, and then you have to write that g of y as the f inverse. Okay. Question 10. Question 10, we have let f from x to y be an invertible function. It is given already invertible. Show that f is unique inverse. Okay, and hint is given. So f from x to y is given to be invertible. Okay. Unique inverse means we have to take some, let's say g1 and g2, be two different inverses, or f has two inverses. Okay. And so for all y belonging to y, g1 of y is equal to g2 of y. Okay. So I'll take f composite g of y, g1 is equal to identity, as it is given to be invertible, of y, f composite g2 of y. Okay. So f of g1 of y is equal to f of g2 of y. So we have to prove that these inverses are equal. So we are taking the condition for invertible. That is, for invertible we check always for f composite g and g composite f. Right? So if these inverses are not equal, then this also is not equal, right? But we are taking this equal and we are showing that inverses are equal. So this implies that g1 is equal to g2. Here the reason is g is 1 1. Invertible means 1 1 and onto is there. Okay. Then next question. This is next question. Question 11. Question 11. It is given a function defined from 1 to 3 to ABC, and you have to find f inverse and show that f inverse of inverse is f. Okay. So it is f is from 1 to 3 to ABC. Okay. First you have to find F inverse. This is F function. G function will be from ABC to 1 to 3, right? Then we have to check for F composite G and G composite F. So F of 1 is defined to be A, F of 2 is defined to be B, and F of 3 is defined to be C. So similarly, we can take G of A to be defined to be 1, G of B to be defined to be 2, and G of C to be defined to be 3. Okay, so let's start with F composite G of A. So F of 1, which is A. Then F composite G of B, which is F of 2, B. And F composite G of C, which is F of 3, C. Same way you have to go for G composite F of 1, G of A, which is 1. G composite F of 2, F of 2. So G of B, which is 2, and G composite F of 3, which is G of C, 3. Okay, so this becomes identity again. So F inverse, that is F is invertible, and G function is this function. This is the inverse of F. Okay. So F inverse is our G function. Now we have to show that F inverse of inverse is F. Okay, so F inverse is G. G is defined from this. Now we have to find G inverse. So G is defined this. I write H to be defined from 1 to 3 to ABC. Then again you have to show H composite G and G composite H. Okay. Now this function is same as F. We'll get this to be equal, that is identity, invertible. G is invertible, so G inverse exists, which is our H, which is nothing but F. So like that we can prove F inverse of inverse is F. Okay. Same way you have to continue. Next, question 12. Let f from x to y be an invertible function. Show that inverse of f inverse is f. That is f inverse of inverse is f. Okay. Here it is already given invertible. Here function is not defined like the one in 11, question 11. Okay. Here they have given in general. So this is given to be invertible. Invertible means what? There exists G from Y to X such that F composite G of Y is IY and G composite F of X is IX. Right? Huh? And this G is your inverse of F. So F inverse is G. Hmm? And yeah. And this G function is defined from Y to X. Okay. Now we'll write F inverse of F. F inverse composite F. So this will be our I of X. Okay. Because this is G. See, this we have, this we got. F inverse is equal to G. So in place of G, I'm writing F inverse. So I'll get the same thing. In place of G, you have to write F inverse. Huh? So this itself proves that F inverse of inverse is F. Okay. Next question is fill in the blanks or yeah. So question 13. F is defined from R to R set of real numbers given by f of x equal to 3 minus x cubed raised to 1 by 3. Then f composite f of x is, you have to find f composite f of x. Okay. So this is f of x. I have to write here 3 minus x cubed raised to 1 by 3. And this whole thing you have to put here. 3 minus, in place of x, you'll get this cube and 1 by 3. Okay. Now this gets cancelled. This will be 3 minus x cube. 3 minus plus x cube. So this also raised to 1 by 3 is there. Then this gets cancelled. You will get x. Okay. So C is the answer. Next is question 14. If R f from R to R minus 4 by 3, this is also minus, defined as f of x equal to 4x upon 3x plus 4. The inverse of f is the map G from range of f given by. Okay. So for this, first we have to find the G function. Okay. And then we have to compute for f composite G, then G composite f. If they are identities, then we can go further, that is, it is invertible, and we can say that inverse exists. Okay. So let's find out our G function. So G function is defined from range of f to r minus minus 4 by 3. Okay. So let's say some y belongs to range of f. Okay. So f of x is equal to y, which is 4x upon 3x plus 4. Okay, so this is 3xy plus 4y equal to 4x. We want x, right? So 4y equal to 4x minus 3xy. So take x common. So this is 4 minus 3y. So our x is 4y upon 4 minus 3y. Okay. So this is our G function. 4y upon 4 minus 3y. Now let's check for f composite G and G composite f. This upon term will get cancelled. Here you have to do the cross multiplication thing. Okay, 12y upon 16. No, this is not 12, this is 16. So you'll get y. Okay. So this we are getting identity. Check for G composite. Again the same thing will come. Again you have to do the cross multiplication here, and the denominators will get cancelled. 16x upon 12x plus 16x minus 12x. So here also x. So both are equal to identity. So we can say that f is invertible, and the inverse is f inverse of y. It is g of y is your 4y upon 4 minus 3y. Okay, so the answer is B. Yes.